So good afternoon to all of you. So welcome back for the final session of this hands-on this RESCU software. So in this session you can do the hand. I think there is some file issue in your bin folder. Whenever you are extracting the file, I think you have skipped some file. So that's why this error is coming, Q sub error. So no issue. We will send you that file in the WhatsApp group. So you can send that error. So you can send the screenshot of that error so that we can send you that file in the WhatsApp group. So please send the error. Yes, this software is valid for the 1 month. This software is given for your evaluation purpose, not for the publication the paper. So if you are planning to publish any papers, so first you need to purchase this software, then you can publish the. So from this trial license you can't publish any papers. So I hope everyone has been downloaded the software and their software is working. So for opening this software, you can go to the C drive, then you will find this devices studio folder. So you can open this devices studio, then this file you will find. Again, you can open this bin folder and drag and drop, then you will find this devices studio application file. So if you want to open this devices studio, first you can go to the C drive, open this devices studio file, then open this bin folder, and inside this folder this devices studio is there. So you can double click on this devices studio application file so that it will be open. This interface will open like this remaining validity period of the product within 1 month. So this is the license that is valid for the 1 month. So you can click on this OK, and then this interface will open. So first you can select this create a new project, and then you can click on this OK option. Here you need to enter the project name. You can enter the project name, then you can select the location where you want to save this project, and then you can select this save option so that your project will be saved. So I can repeat once more time. So for opening this software, you can go to this C drive, select this devices studio folder, select this bin folder, and select this devices studio application file. You can double click on it. So you can double click on it, then it will be open. Here you can see this interface will open. So you can click on this OK, and you will find this interface. So first you can select create a new project. You can click on this OK option. Here you need to enter the project name. Here you can enter the project name. Then you can click on this save option. So once you create a project, you will find this interface. So this session is for the hands-on. So you need to follow the same procedure that I will show. So first I will show you how to calculate the DFT simulation, and after that I will show you how you can do the DFPT simulations. In this hands-on I will take a less number of atoms, because once you increase the number of atom, then this software will take some time to simulate the structure. So it is better in the hands-on to take the some small number of atoms so that you will get the faster result. And after this hands-on you can create your own structure. Any number of atom you can create, and then you can do the simulations. But in hands-on you can take less number of atom, and then you can do the simulation. So first you can import some material from this local database. So you can click on this file option, select this import option, and then go to this import local option. So for importing any material from the existing database, you can select this file option, select import option, then select this import local option. And then you can go to your C drive, select this devices studio, and in device studio you will find this material folder. So this is the material folder. You can open and you will find this material database: 0D material, 1D material, 2D material, 3D material, and some organic materials. So you can select this 3D materials, select conductor. So you can go to this 3D material, select conductors, select this pure metal, and you can drag and drop and search the nickel. So you can select this nickel pure metals, and then you can click on this open option. So you can drag and drop, search this nickel pure metals, and then you can select this open option. So once you click on this open option, then it will be loaded in your dashboard. So this is the nickel crystal structure that I have imported from my local database. So I hope everyone has been imported this nickel pure metals from this existing database. So for simulating this structure, you can select this simulator, select this rescue, and select this SCF calculation, self-consistent field calculation. So this calculation is for the DFT, density function theory, and this is the density function perturbation theory. So first you can select this DFT simulations. So this is the self-consistent field calculation for this nickel crystal structure. You can define your own parameter as per your need.
Sir, in the place of nickel, can we search another compound?
Yes, ma'am, you can do.
Sir, how to take two compounds like MO and S2?
So for
Yes, sir.
MOS2, yes, for
Sir,
MOS2, you
Sir,
can select. Yes,
morning you explain one compound, na? Sir, please can you explain dopant's compound now?
yes, ma'am. I will explain it.
Yes, sir.
So this is the file option. If you want to import MOS2, select this import. Select this import local. Either you can select this import online option, and here you can enter MOS2. Then you can search. Here you can see this is the MOS2 with different space group are there. So as per your need, you can select this structure, and then you can select this add option. Then this structure will be loaded. Or if you want to import from this local database, so you can select this file option, select import option, go to this import local, select this 3D materials. This is the 3D materials. Select layer materials, and here you can see this is the MOS2. So you can select, and you can select, and then you can select this open option. Then it will be loaded. So this is the nickel crystal structure. For simulating this structure, you can select simulator, select rescue. First you can define the DFT parameters. So for this you can select this self-consistent field calculation, and here you can define the parameters. So input parameter you can define. You can define the basic settings, simmering sigma. You can define the resolutions. So if you want to change, so you can change the value like that. So this is the method. You can see this is the real space, and this is the linear combination of atomic orbital. So you can select this linear combination of atomic orbitals, and this is the exchange correlation function. So this is the LDA, GGA, meta GGA, hybrid function is also there. So I am taking the default parameters LDA, and then you can define the K point sampling. So if you want to define the K-point sampling, N1 is equal to 9, N2 is equal to 9, and also you can define the N3 is equal to 9. So this is the K-point sampling you can define. So first you can define the sigma 0.01 electron volt. You can define the resolution 0.3 Bohr. You can define the method linear combination of atomic orbitals. This is the exchange correlation function. You can define the K-point sampling. N1 is equal to 9, N2 is equal to 9, and N3 is also 9. So you can define these parameters. Then select this iteration control. So here you can see this is the tolerance.
Sir,
Yes, ma'am.
sir, these parameters we see from the literature.
Yes, ma'am. You can visit the theory part. This is the
Okay.
nanoacademic.com. This is the document and tutorials. And here you can select this rescue. So this document and tutorials are there. So this is the iteration control parameters. And this is the basic settings. So here you can see this is the double zeta polarized neutral atomic database. Then you can select this spin type. And if you want to include the spintronics application like collinear spin, general spin, so in this structure I would like to include the collinear spin. So you can select this collinear spin, and then you need to generate the input file. And if you want to change the maximum value, so you can also change. So as per your need you can change. So once you define the parameters, input parameters, then you can generate their input file. So this is the basic settings, this is the iteration control, this is the basic settings, and this is the spin type. And then you can select this generate file option. So I hope everyone has been generated their scf.input file and atom.xyz file. So here you can see this is the nickel folder, this is the nickel folder, and this is the rescue crystal folder. Here you can click, then you will find this scf.input file and atom.xyz file. So if you want to show the script, you can select this scf.input file, right click and select this open with. So this is the script for this nickel crystal structure with DFT method. Here you can see what parameter we have defined. All the parameter are mentioned. Here you can see this is the collinear spin. This is the nickel atoms. Their neutral atomic database. And this is the exchange correlation function. So there is no need to write the script. So once you define the input parameter and click on generate file, so this software will automatically generate their input files. And this is the atom.xyz file. So in this file you will find the Cartesian coordinate point of this nickel atoms. So you can select this open with. Here you can see this is the nickel and their Cartesian coordinate point. So for running this scf.input file, you can select
Sir?
this scf.input. Yes.
How are you rotating the structure?
Here you can see this is the rotate option. You can select and you can rotate. So this is the scf.input file. You can select, right click, and you can select this run option. So for running this input file, you can select that input file, right click and select run option. Here you can select this run option to run this job. So once you run the input file, in the bottom of the page you will find our scf.input file is in the running condition. So this is the job manager. where my escape input file is in the running condition. So in the meantime, if you want to analyze the properties from this structure, so you can select this simulator, select this rescue, and then go to this analysis part. So for generating analysis input file, you can select simulator, select this rescue, then select this analysis. So for the band calculation, you can see this is the band structure, this is the density of state, this is the molecular population, and this is the potential. So you can select this band structure and double click on it. Then it will be selected. Here you can see our band structure has been selected. So this is the band structure and their parameters. Here you can see this is the symmetry K point. And if you want to show the Brillouin zone path, so you can select this path option. And this is the Brillouin zone path for this nickel atoms. So if you want to change the symmetry high point, so you can also change as per your need. So for showing the Brillouin zone path, here you can see this is the path option. You can select and then this interface will open. You can see this is the Brillouin zone path.
Sir, but I am not able to select this path.
Ma'am, did you get this interface?
Yes, sir.
And this parameter are there?
Yes, sir.
But this path option is not enabled.
Yes, sir. But path option is not enabled.
Can you send the screenshot?
Okay, sir, I got it. Now it is enabled.
So this is the Brillouin zone path for this nickel crystal structure. If you want to delete any high symmetry K point, so you can also delete. You can select that symmetry point and select this cross option. Here you can see this is the delete option. It has been deleted. So as per your need, you can change and then you can preview, then you can apply. And also you can move any symmetry point up, down side. Like you can see, this is the L high symmetry K point. If you want to move on the upside, so this is the upside and this is the downside.
I'm unable to make any changes in this Brillouin path window.
So first you can select that point. Like you can select this high symmetry K point, then you can change.
Yeah, but nothing is happening in the crystal structure. Like neither can I rotate it nor can I select the point.
If you want, here you can see this is the path option. You can select and then you can do the changes. Like if you want to include a new symmetry K point,
Can you
so you
please
can
go
select
back
this.
to the analysis window?
Yes, ma'am.
Can you please go back to the analysis window? Like
Yes, this is the
in
analysis.
my case, the empty band, then wave function calculate. These are all disabled. So
I think, ma'am, you did not follow the same procedure that I am showing you. I think you have done some mistake. So you can select the structure first. Here you can see the structure has been selected. Then go to the simulator, select this rescue option, then go to the analysis part. Then this option will be enabled. Here you can see this is the enable. This is the density of state band structure. So you can select this band structure and select this total number of K point. Also you can change their value if you want to change. Like here you can see this is the 250 number of K point and this is the density of state. So this is the density of state and their parameters. So you need to define some K point sampling so that your data will be plotted. So before generating any input file for this density of state, first you can define their K point sampling, then you can generate. So I would like to change this value. N1 is equal to 15. N3 is also 15. N2 is also 15. And you can also change the N3 is equal to 15s. So this is the K point sampling, and here you can see this is the energy range, number of energy point, and this is the K point sampling method. So this is the Fermi direct method, this is the Gauss method. So you can change the K point sampling, you can select the K point sampling method Gauss, you can define their signaling sigma 0.1 electron volt, and then you can generate their input file. So this is the density of state parameters, and this is the band structure parameters. So once you define the parameter, click on generate input file. So in the bottom of the page you can see the scf.input file has been completed. So in the same way you can run this band structure.input file and this density of state.input file. So for running any input file, you can select that input file, right click, then you can select this run option, and here you can select this run option to run this job. You can see this band structure.input file is in the running condition. Similarly, you can select this density of state, right click, and select this run option. Here you can select this run option to run this job. So once this simulation will be completed, then you will get the output file. So I hope everyone has been run their input file, SCF input file, band structure.input file, density of state.input file, and their simulation has been completed. So you can wait till the simulation finished. So once this simulation will completed, then you will get the output file. And if anyone getting any error while simulating any structure, so after this hands-on you can drop the, yes, after this hands-on you can drop the message in the WhatsApp group, so that I will help you. So once your simulation will complete, you can click, you can select any input file, right click, and select this open containing folder. So once your simulation will be completed, you can select any input file or output file. So here you can see this is the rescue log.output file, right click, select this open containing folder. So once you select this open containing folder, then you will get the location of this project, their input file and output file you will get. Here you can see this is the location of my project, this is the input file, and this is the result folder. So this is the location, this is the input file, band structure input file, density of state.input file, scf.input file, and this is the rescue log.output file. This is the atom.xyz file, and this is the result folder. In the result folder you can see this is the band structure output file in the text format, this is the real space density, and this is the density of state, and also you can see this is the potential. So once your input file will be completed, then you will get the output file. And once you get the output file, so if you want to plot the graph, so select this simulator, select this rescue, select this analysis plot. So for plotting the any graph, you can select simulator, select this rescue, select this analysis plot, and then you need to locate this project. So you can go to this location, then you will find the output file. Select simulator, select rescue, select this analysis plot, and here you can select the project location. You can see this is the location of my project, this is the nickel folder, This is the rescue crystal folder, and this is the result folder. In the result folder, you can see this is the band structure, this is the real space density, this is the density of state that is in the text format. So for showing the band structure plot, you can select the band structure file and select this open option. So this is the band structure for this nickel pure metals. So this is the band structure for the spin up calculation. In the spin tab, you can see this is the spin up, this is the spin down, and this is the both spin up and spin down calculation. So you can select one to one, like this is the spin down simulation, and this is the both spin up and spin down. So red one is for the spin down and blue one is for the spin up simulation.
Excuse me, sir.
Yes, sir.
So can you please
Hello.
repeat
Yes, sir.
how to get the results?
Yeah.
So once your simulation will be completed, then you can select this rescue log.output file, select this open containing folder, and you can see this is my project location, this is the input file, and this is the result folder. Again, you can select your device studio, and for plotting the graph, you can select simulator, select this rescue, select this analysis plot, and then you need to locate your project. Here you can see this is the location of my project, this is the nickel folder, this is the rescue crystal folder, and this is the result folder. So you can open the result folder, then you will find the output file. This is the band structure, this is the real space density, this is the density of state, and this is the potential. So first you can select this band structure, select this open option. So once you select, then you will find the graph for the band structure.
Hello.
Yes, sir.
Sir, can we export these data files like to text or some Excel kind of sheets?
Yes.
So that
If you
we can
want to
plot
export this
elsewhere.
raw data in any format, so in the left hand side you can see this is the export option. You can select, and then you can need to select the file format like PNG, JPG, BMP, PDF, TIFF format. So any format you can select. Then you can choose the location, like this is the desktop, and this is the JPG format, and this is the desktop. Then you can select the save option so that you can easily export your raw data in any format.
It's like you are exporting graphs only. I'm asking about raw data files, like so that we can plot from origin or Excel.
So here you can see this is the rescue log.output file. You can select this file, right click, select this open containing folder. Then this interface will open. So you can select this result folder, and this is the output file. So
Okay,
this
so
is
using these text files, we can plot.
yes,
These
either origin, any
graphs.
third-party software you
Okay.
can plot.
In the band structure plot that we have obtained, the symmetry points are shown as exclamation marks only. So how can we find the gamma point and all?
In the input file, you can see this is the open with, and here you can see this is the symmetry K point, U, X, G, X, W, K. So you can open your graph. This is the U, this is the X, G, X, W, and so on. And if you
Okay.
want to show their value at a symmetry point, what will be the value? Then you need to import this file in the MATLAB. So from this browse option, you can locate your project into the MATLAB. You can see this is my project. You can select folder, and then this folder will be selected. This is the nickel folder. Their input and output file will be there. This is the input file, and this is the result folder. You can see this is the nickel band structure .mat file. So you can double click on it, then it will be loaded. Their data will be plotted here. Here you can see this is the data. Here you can see this is the 3K point, and all this data are there.
Excuse me, sir. Can you explain again this portion how to plot in that MATLAB?
Okay, no sir. So you can open your MATLAB, select this browse option. This browse option you can select your project location. Here you can see this is my location of project, device studio project, and this is my project, second session on RESCU. You can select this project, then select this folder. So once you select this folder, this file will be there. So you can click on this plus option, then you will get this RESCU crystal folder and this nickel double data polarized .mat file. Again you need to open this plus option, then this result input and output file will be there. This is the input file, this is the output file. Here you can see this is the nickel band structure .mat file, and this is the nickel density of state .mat file. So you can double click on this nickel band structure .mat file, then it will be loaded and their data will be plotted here. This is the band structure. Here you can see this is the data. So this is the data, this is the K point.
Sir, this workspace is not coming in the right side. How? I don't know. Why? I don't know.
Did you get in the right side, left side?
Only that command window only it is showing.
So you can select this layout, and you can select this default setting. Then again you can select this browse option. Again you need to locate your project.
Then again that I have to double click on that BS in .mat. Yes, your workspace came in it down, means left side down it came, not it's coming right side. Now it's came.
So this is the band structure, and if you want to plot this density of state output file, select this simulator, select this RESCU, then select this analysis plot, and this time you can select this density of state. So you can see this is the density of state with respect to energy for this nickel atom, and you can see, and this is for the spin up simulation. In the spin type you can change. This is the spin down, and this is the both spin up and spin down. So blue one is for the spin up simulation, red one is for the spin down simulation, and this is the both spin up and spin down. So I hope everyone has been plotted their output file. So once you do the simulation, you run the input file, then after the simulation completed, then you will get the output file, and from this analysis plot you can plot any output file, either band structure, density of state, potential, Raman property, optical property, you can plot. So this is all about this density function theory simulation. So if we talk about this density function perturbation theory, where you can simulate Raman property, dielectric properties, phonon density of state, phonon band structure. So this time you can take another example. So if you want to simulate for the aluminum nitride, so you can select this file option, select this import option, select this import online option. So for calculating the Raman properties for this aluminum nitride, first we need to import that materials
Hello.
either from this local database. Yes, ma'am.
Sir, can you please tell how to create a composite material?
Yes, ma'am. Any composite material you can create. If you
Okay,
want to
can
create your own composite material, then you can select this crystal option,
okay.
and then you can define their parameters. And if you want to import from this import local option and import online option, so this is
Like
the
any
import option.
semiconductor with graphene, oxide,
So if you
semiconductor
want to,
oxide,
graphene is in the 2D materials.
right? And zinc oxide material,
Zinc oxide is 3D materials. You will get in the metal oxide.
right? So can we create a composite material using these two?
Graphene and zinc
Zinc
oxide.
oxide, G.
Yes, we can create.
So please tell me how.
So you can see this is the zinc oxide. You can import, select this graphene. So this is the graphene and this is the zinc oxide. So if you want to mix this graphene and zinc oxide, so this is the graphene. You can copy, Control C and Control V in the zinc oxide. So either this way you can mix the atoms, either you can first create the complex structure of the zinc oxide graphene structure, like and then go to the interface builder. Here this is the zinc oxide and this is the graphene. Here you can see this is the composite between this graphene and zinc oxide.
Sir, can you please repeat one more time?
Okay, so first you can import that material that you want to mix. So first you can do, you can select this graphene, Control C, select this zinc oxide and Control V here, and you can choose the location where you want to choose. This is the move option. Anywhere you can select the location as per your need, or you can go to this build option, select this redefine interface builder. In this structure you can select zinc oxide. From this option you can select, and in the structure B you can select the graphene. So once you select this structure, you can click on this match option and select this preview option. And here you can see this is the total number of atoms, 48. So if you want to increase the number of atoms, you can click anywhere in this graph, and here you can see the atom has been increased. So you can follow this procedure to make a composite material.
So when I have imported two materials, it is showing that the theta is different. So what am I supposed to do?
Ma'am, which material you are importing? Can you?
Yeah, I have imported Nb2C and cerium oxide.
So if their value are changed, so one thing you can do, you can select that input file.
Okay.
Go to this convert to crystal option, and then you can create their vacuum energy. So their vacuum energy should be same, so that you can get the interface.
Okay, can you show me where that convert to crystal option is?
Ma'am, can you tell me the material which you want to create a composite?
I just wanted to make a composite out of NB2C,
NVC2,
NB2C,
the NV2C. Okay.
with anything
So
would
this
be fine.
material is there or not in the database?
Yeah, it's there in the online, and not in the local one, in the online one.
So this has been selected,
Yes, sir.
and another one.
Anything would be fine, sir.
Okay.
Zinc
So I
oxide
can
would be
take,
fine. Yeah.
okay, I can take this zinc oxide,
Okay.
build option, interface builder.
Mm.
Here you can see there is no error are coming. So this is the zinc, and this is the NB2C1.
Okay, I shall
Select
try.
this match option,
Mm.
and here you can see this is the composite between these two.
Okay, sir. Sir, is it the most stable form? Is there any way by which we can find that? Which atom would be attached to which atom? Anything?
Hello, yes, ma'am.
Sir, can we find out the most stable form of attachment between at the interface?
Ma'am, then you need to go to the theory part, and then you will get the stable of the any
Oh.
atoms.
All right, all right.
Sir, can you please
Sir,
show
can you
the
show me how how to
FCM
create
into ZNO?
how how to create the vacuum?
So for creating any vacuum, you can select that structure, select this convert to crystal option, then you can change their vacuum energy.
For this.
Ma'am, your voice is breaking.
So where do I get the tutorial? Tutorial for this?
Ma'am, you can visit our website, nanoacademic.com. This website you can visit,
Okay.
and then go to this document and tutorials. You can select this rescue.
Huh.
Here you can see this is the tutorials.
Okay, thank you so much.
Sir,
And
please can you show the ZNO into yttrium?
this is the zinc oxide.
Okay, sir.
Then what do you want from this zinc oxide?
With yttrium doped, sir.
Ma'am, which oxide?
Zinc oxide.
Ma'am, this is the zinc oxide.
Yes, sir. Yttrium doped zinc oxide.
Ma'am, can you type in this in chat box? So if you want to doping deuterium doping in the zinc oxide,
Yes, sir.
select the simulator, select this numerical,
Okay.
select this virtual crystal approximation,
Okay, sir.
select this mixer atom. From this periodic table, you can select the deuterium.
Here.
So once you select it, then you can define their composition value.
Sir, not YB. That one is YB. Yttrium, yttrium.
Only Y.
Only Y. Y.
And then you can define their composition value,
Okay.
and then you can generate their input file. So
Okay.
once you click on generate file, then their input and output file will be created.
Okay, sir.
Second. How to do?
Here you can see this is the
Sir,
virtual
how
crystal.
can we label that bounds and symbols? Hello.
Yes, ma'am.
How can we label this structure in symbols?
Okay, first one second. Here you can see this is the label option.
So first you go to the right clicker, sir, in the picture.
Yes, in the picture you can right click
Okay.
and select this label option.
Then
you can click on this apply.
okay, sir.
Here you can see this is the item first, second, third, and fourth one.
Okay, sir.
And if you want to show the atom and their position, so you can select this display atoms, and here you can see this is the zinc and this is the oxygens and their xyz fractional coordinate point.
Okay, sir. Sir, 1 to 3, which bond it is there, sir, in between the 1 to 3? Whether it is oxygen bond or hydrogen bond, how can we find the bonds?
This is the covalent bond.
Oh, covalent bond, okay.
Sir, I had a problem. I am unable to merge these two compounds because with the graphene, when I mix with another compound, that is coming outside the unit cell.
So sir, which compound you are creating?
Sir?
With the graphene, which atoms you are creating?
With a nickel zinc ferrite.
Zinc oxide.
Nickel zinc ferrite. It's I have taken from online, imported from online. Nickel zinc ferrite. I will type.
Yes, you can type. And if the structure is not creating from this interface builder, then you can select this structure.
Yes, I have taken from online. So compound name I have given.
So sir, for creating any complex material, if the material is not getting interfaced, then one thing you can do, you can select that structure, either any structure you can select, go to this convert to crystal option, and you can match their vacuum energy. First you can match their vacuum energy for both the atoms. Then go to this interface builder, then your material will be definitely interfaced.
Okay, could you please tell me about this vacuum? The value should be same in both, for both?
Yes, both.
Okay, same value that I have to give in, like
yes.
A value. Only A value I have to change, or rest of the values also?
You can select any structure, like if you want to, like this is the zinc oxide.
Okay.
I can check their vacuum energy here. This value I can check, and then again I can select this graphene, then go to this convert to crystal option, and this value I can match.
How do I go for convert to crystal option?
In the toolbar you can see this is the convert to crystal option.
There, sir.
This is the toolbar. In the toolbar you can see this is the convert to molecule, this is the convert to crystal, and this is the convert to device. So middle one is for the convert to crystal option. So this is the DFT simulation, and DFT simulation. First, you can import some material from this online database.
Sir?
Yes, ma'am.
Sir, what if our material is not here available on import online also?
Ma'am, are there? Can you repeat?
If our material is not available there in import online?
If any material is not there, either in the import on local option, either import online option, then you can select this file option, select this new option, then you can create your own material from this crystal builder. Either from crystal builder, you can create your own molecule structure from this builder. So for making a crystal, you should know their space group, Brebes lattice parameters, ABC value, alpha beta gamma value. You need to add the element, and you should know their fractional coordinate point. Then you can create any crystal structure.
Okay, sir.
Am I audible, sir?
Yes, sir.
Actually, I want to know that can we find out the stability of nanoparticles submerged in water or any kind of fluid? Is it possible?
Yes, sir, it's possible. But I can check this point stability for any nanoparticles. Then I will confirm to you.
Yeah, fine. Thank you.
Can I go for the DFPT simulation? Sir, any CIF file you can import and you can do the simulation from this RESCU software. So here you can see this is your CIF file. I can download. This file is there. So I can open my device studio, select this file option, select this import option, select this import local option, go to this download option, and this is your file, CIF file. I can select, I can open. So this is your structure that I have imported. So once you imported your structure, for simulating any structure, you can select simulator, you can select the simulator, rescue, nanodical, any simulator you can select, and then you can do this simulation. So this is all about this DFT simulation.
Yes, sir, but I am unable to run this zip file. It
So
is
you can see, if I would like to create their input file, first you can generate their input file. Here you can see the input file has been generated, and then you can simply run from this option. First you need to run generate their input file, then you need to run. Here you can see run option is enabled. So this is the DFT simulation. This is the DFT simulation. And if we talk about this DFPT simulation, so I can import some material from this online database. So if you want to create a Raman spectrum for the aluminum nitride, so you can select this import local option, online option, and you can search here aluminum nitride. So this is the aluminum nitride. You can search. So here you can see this is the aluminum nitride with different space group. So this structure you can select, and then you can click on this add option. So for importing aluminum nitride, you can select file option, select import online option. Then you can enter the chemical formula, like this is the aluminum nitride. Then you can click on this search option. So you can select this structure and then click on this add option. So this is the aluminum nitride that I have imported from my online database. So I hope everyone has been imported this aluminum nitride from the online database. So once you import it, for simulating structure, you can select this simulator, you can select this rescue, then you can select this DFPT, density function perturbation theory. So for doing the DFPT simulation, you can select simulator, select this rescue, then you can select this density function perturbation theory. And in the task, you can select this Raman spectrum, Raman property calculation. So in the task, you can select this Raman property calculation, and then you can define the parameters. This is the simmering sigma, this is the resolution, this is the SCF method, Realspace, this is the exchange correlation function, this is the K-point sampling, this is the iteration control. Here you can see this is the SCF parameter, and this is the DFPT parameters. In the DFPT method, you can see this is the Sternheimer, and this is the Chebyshev filtering solver. So this Sternheimer has been selected. This is the basic set. This is the aluminum. Their neutral atomic database, double zeta polarized. This is the nitrogen, and their double zeta polarized. This is the spin type calculation, and this is the Raman and their parameters. Here you can see this is the Raman parameter, damping factor. You can define the key point Cartesian, income photon polarization, outcome photon polarization, income photon wavelength. You can also define the temperature in the range of Kelvin. So here I am taking the default 100, 010, 010. This is the value of wavelength, and this is the temperature. So once you selected the parameters, then click on this generate file. So once you click on generate file, in the project explorer you will find scf.input file, dielectric.input file, phonon.input file, and Raman.input file. And for their position fractional coordinate point, you can see this is the atom.xyz file. So you can run all the input file from the top to bottom. So first you can run this scf.input file. You can select that input file, right click, select this run option. So in the queue condition, you can run all the input file. So this is the SCF input file. This is the dielectric.input file. This is the phonon.input file. And this is the Raman.input file. In the job manager, you can see I have run all the input file in the queue condition. Like this CSF.input file has been completed. Then this dielectric.input file will start running. Here you can see this is in the running condition. So multiple input file you can run in the queue condition, and you can wait till the simulation finished. So once this simulation finished, then their output file will be generated. You can see this scf.input file has been completed, and this dielectric.input file is also completed, and this phonon.input file is in the running condition. And for showing their step-by-step procedure, you can see this is the rescue log.out file. You can select this file, right click, select this open with. You can see this is the self-consistent calculation. You can see this is the Realspace method, and then step-by-step procedure for the SCF calculation. So this CSF simulation has been completed. Now this dielectric input file is in the starting. So this DFT dielectric input file is starting from this option. Here this simulation has been completed, and now this phonon.input file is starting from this point. Now this Sternheimer is enabled. Here you can see all the simulation has been completed. So if you want to show the output file, you can select this rescue log.out file, right click, select this open containing folder. So this is the input file, SCF input file, Raman.input file, phonon.input file, dielectric.input file, and this is the atom.xyz file, and this is the result folder. You can see this is the dielectric output file, this is the phonon output file, and this is the Raman output file. So for plotting the graph, you can go to this devices studio, select this Raman.input file, right click, select this open with. So if you want to plot this Raman output, you can select this Raman.input file, select this open with, and here you need to write the script. You can write this rescue. This is for plotting. You can copy this location. So this shape path you can copy. So from this dot point to Raman, you can copy, Control C, and you can paste here. This is the Raman, and here you can include .mat file. So this is the .mat. So this script you need to write for plotting the graph. So once you write this script, you can select this save file option, so that this file will be saved, and you need to run this Raman.input file again. So you can write this script. You can click on this save option. Then this file will be saved. You can cancel, and you can select this Raman.input file. Right click. Then you need to select this run option. Here you need to run again. And once this simulation will finished, their output file will be generated. Here you can see the plot has been generated, and that plot will open in the MATLAB. So any third party application you can open either in Origin, MATLAB. Again, you can select this browse option. You need to select your location of the project. So this is the Device Studio project file, and this is my file. So from this browse option, you can locate your project into the MATLAB. So you can select this file and select this select folder option. Here you can see this is my project name. This is the nickel, and their input and output file will be there. This is the zinc oxide. This is the .cif file that I have imported. This is the aluminum nitride. So all the input and output file will be imported in this MATLAB. So you can double click on your aluminum nitride. So this is the RESCU DFPT folder. Again, you can open this RESCU DFPT folder, double click, then it will be open. So here you can see this is our input file.
Sir,
Yes ma'am, tell me.
can you please repeat that how to export to MATLAB?
So you can select this browse option. Then you need to select your project. Here you can see this is the location of my project. You can select this file and select this select folder option. Here you can see my project has been imported, and we have simulated the Raman spectrum for this aluminum nitride. So we can open this aluminum nitride file. So you can double click on this file. Then you will find this RESCU DFPT folder. Again, you can open this RESCU DFPT folder. Then you will find this input file and their graph. Here you can see this is the result folder, and this is their graph that we have simulated from this option. From this this script we have simulated. So this is the aluminum nitride Raman plot for the polarized. So you can double click on it. Then you will get the plot for this aluminum nitride. So this is the Raman polarized graph between the Raman intensities and Raman shift. You can see this is the Raman shift and this is the Raman intensities. So this is the polarized graph and this is the average graph. You can see this is the aluminum nitride Raman plot for the Q1 average polarized graph.
Sir, excuse me.
Yes, sir.
How will get exact features of these peaks like the FWHM and exact position, intensity, like kind of intensity is there, okay, but FWHM and peak positions.
FWHM.
Full width at half maximum or width of half width of these peaks. Or without these features, we cannot.
So here you can see this is the maximum peak frequencies for this Raman spectrum. This is the maximum
okay.
one.
Okay, it's coming like X position 357.45. Okay.
Yes, this is the X position and this is the Y positions.
Okay. So
Sir, you can visit out this website so that you will get.
no, sir. Actually, I will see. Because text file is there, so I will plot elsewhere.
Yes, sir.
No
Text
issue.
file is there.
Excuse me, sir.
Yes, ma'am.
Actually, in that MATLAB, that figure options is not coming for me.
So, ma'am,
Only
this figure
this
option,
input
yes, ma'am.
files. Yes,
This
sir.
figure option will come once you write this script.
That I did. Already I did, and I have to save, right?
Yes, you can write here. You can click on this save option, and then you need to run this input file again.
Then I have to run. Yes.
Yes, yes. Then you will get the output file.
Okay. Then after that, I have to browse this folder,
Yes,
right?
yes, yes.
After doing,
And also you can visit our YouTube channel where you will find all this. You can visit Impulse Technology Innovative Research, and this is our YouTube channel. In the playlist, you can see this is the rescue softwares videos. Raman spectrum. You can also see this is the phonon band structure, phonon density of state. This is the optical properties. So all the tutorials video are available, so you can watch. So this is the Raman property calculation. So you can follow the same procedure for simulating either phonon band structure. Here you can see in the task you can select the calculation. So either you can select phonon band structure, phonon density of state calculation, phonon band structure and phonon density of state, optical property calculation, and Raman property calculation. So you can select any calculation. You can define their input parameter, then click on generate file option. So once you generate the file, you will get this input file. Yes, you have dielectric.input file, phonon.input file. Either you can generate Raman.input file, optic.input file, phonon band structure.input file, or phonon density of state.input file. So you can run from top to bottom. And once this simulation will finished, you can open that input file, either Raman, optical, phonon, and you need to write this script. So in the Raman you can include Raman, in the optical you can include optic, in the phonon band structure you can select PBS, and in the phonon density of state you need to write PDOS. Then you need to save the project.
Excuse me, sir. Can you type that comment in the comment boxes? Sir, please type that comment. It's not visible.
Okay, Manoj, I can write. So you can check the WhatsApp group. So once you do the simulation, and for plotting the graph, this is for the Raman. And if you plot for the optical, so here you can include the optic. If you want to plot the for the band structure, phonon band structure, then here you need to include the PBS for the phonon band structure. And for the phonon density of state, you need to enable phonon PDOS. So you can write this script. You need to save this input file, and you need to run that input file again, so that you will get the plot. And also you can measure the distance between any atoms. Here you can see. So if you want to measure the distance, in this toolbar you can see this is the distance measurement. You can select any two element, then it will measure the distance. Here you can see this is the distance 1.902 angstrom between these two atoms. So this is the distance measurement. This is the angle measurement. So the angle between the three atoms you can measure. So this is the angle measurement. You need to select three atoms. You can see this is the angle between these three atoms. And also if you want to measure the dihedral angle measurement, like the angle between the 4 atoms, so here you can see this is the dihedral angle measurement. So you can select 4 atoms, then it will measure the angle. And also you can measure the vector value. Here you can see this is the vector measurement. You can select any 2 atoms, and this is the vector value between these 2 atoms. And also you can see this is the delete option. So if you want to delete any atoms, first you can select that atoms, then select this delete atom option. And this is the 3D viewer, where you can see like XY view, XZ view, YZ view, YX view, ZX view. Like this is the XY view, this is the XZ view, this is the YZ view, this is the YX view, and this is the ZX view. As I have told you earlier, like this software support this file format. So if you have this file format, then you can easily import in our device studio. .szw, .xyz, .cif file, .xsd postcard, container, .scf input file. So all this file format you can easily import in our device studio. And if the file format is not available here, is not supported, then you can select this build option, select this convert file option. So you can convert your existing file format into .szw, and then you can import that SZW file in our device studio. So convert file option is also there. So in the simulator you can see this is the nanodical, that is for the atomistic quantum transport simulator for the DFT and the NEGF method, where you can simulate the device properties and material properties. So material as well as device simulation you can do from this nanodical software, and only material simulation you can do from this RESCU software. And this is the nano scheme for the tight bonding model of nanostructure. And we are also organizing a free webinar on this quantum technology spin qubit device simulation, that is for the finite element method. So this is the ticket software. So if anyone is interested in this quantum technology free webinar, so we will provide you the registration link, so you can register and then you can join our webinar. So this is the spin qubit device simulator for the semiconductor application.
Sir,
Sir,
if you
can we join our supercomputer to with that gateway?
Yes, then it will take less time than this
Oh, so is, what is the way to? Hello.
Yes, sir. Yes, sir.
Sir, what is the way to link our that system with this software?
Here you can see this is the machine setting option.
Okay.
And you can select new option.
Okay.
And you can select their host ID, host IP address, port address, their username, their password.
Okay.
So all this setting you can do. Then you can connect your remote access to your own software, own system.
Okay, sir.
Is it possible to introduce some kind of vacancies, maybe oxygen vacancies in our system, and then optimize the structure and obtain the lattice parameters with the software?
Yes, ma'am, you can do. So if you want to optimize any structure, like this structure you want to optimize, select simulator, select this rescue, and then go to this relax option. This is the relaxation. You can select the method, quasi-Newtons, step descent, conjugate gradient, and then you need to generate their input file. So here you can see the input file has been generated, and then you can run this relax.input file. So once this file will finished, once this simulation will finished, then it will generate a file relax atom relax.xyz file. So then you will find there like lattice parameters, atomic positions after the optimization. So once this simulation will finished, it will generate a file, and in that file you will find the lattice parameters, atomic position of the atoms.
Okay, sir. So for introducing the vacancies, what is the procedure? Can you?
So if you want to include the vacancy, so I am creating a complex structure. So if you want to create a oxygen vacancies anywhere, you can select that location. You can select that location, that atom you can select this replace atoms, select this oxygen. Here you can see this carbon has been changed with the oxygen atoms.
Sir, actually, I was asking about removing an oxygen atom. Maybe some kind of metal oxides are there, like you said, no, and we are removing a single oxygen from the lattice. Is that possible?
Yes, you can remove. You can select that atoms, click on this, delete it.
Oh, okay, sir. So in some, actually, I'm working with other softwares, and when we simply delete the a single atom, the symmetry breaking will occur, and a proper optimization won't take place. So will that be an issue in this case also?
So from first here you can delete the atom, then you can do the optimization. Then the optimized structure will be generated.
Okay, sir.
Sir, can we keep a CO2 or O2 molecule with this graphene structure, and can we calculate the binding energy or free energy?
Yes, sir, we can calculate. So any graphene or CO2, any oxide, metal oxide you can select. Like any structure you can select. Simulator. Generate this input file and you can run. So for finding the like band energy, Fermi energy, conduction band, you can select this band structure and generate their input file. So once this simulation finished, then it will generate a band structure output, and in that file you will find the band energy, Fermi energy, and for the conduction band, a valence band as well.
So can we get the optical properties like refractive index
Yes, ma'am. I have already shown you like a.
or any dielectric properties, permittivity?
Yes, ma'am. We can. I can open my project. Here you can see the simulation has been completed. Here you can see this is the optical properties. Here you can see this is the dielectric permittivity for the real axis, real part, and this is for the imaginary part. So this is the dielectric permittivity, and this is the reflective index.
Thank you.
So from my side, thank you so much to all of you for joining this hands-on training on this RESCU software. You can work on this RESCU software, and if any queries arises, then you can let us know so that we are ready to help you.